So this uses the MPI stands for. Suddenly, got that in my head, come back in a minute. Message passing interface. It's a standard for implementations of multi-threaded applications. In fact, MPI is really intended for running on clusters, right, where you want to run different processes on different machines. So the particular implementation that TauDEM V5 uses is MPI CH2, which comes from the Argonne laboratory in the States. It supports actually both the first one and the more recent second standard. It's open source, they say, it's high performance, I suspect they're right, and it's widely portable. They run clusters involving, heterogeneous clusters. So you can have Windows running on one machine and Unix running on Windows running on another and so on. We're using a very much simplified, or at least a cut-down version, or at least we only use some of the facilities. So we're only talking about multi-threading on one machine. I think TauDEM has got implementations where it runs on clusters, but it obviously have, because the graph on the right, this is his foil, talks about 128 processor cluster. But if we talk about running on one machine, he's got an example here, he's got a pre-C with 8 processors, then he gets something close to inversely proportional to the number of processors. So if you have 3 processors, it runs close to a third of the time, which I'm surprised at, if you got it so good. It does, of course, do a slight trick, because he separates the computing time from the total time. Total time tends to go up because you get more overhead, the more processors you have, and because you've got the problem of splitting the thing up into many pieces and then reassembling it at the end. So that's why the black line tends to start to drift above the blue line. But most of us don't have PCs with 8 processors on. So what happens when you run it on something more mundane, something you're more likely to have? So this is my laptop. It's a few years old now. It's only got 2 cores on it. And the D8 flow directions is one of the longest running of the TauDEM tools. And I took the biggest DM I could find, which is actually 6,000 by 6,000. So if you know about SRTM 90-meter DMs, it's a whole one, a big one. So it's 36 million cells. And I ran it with various numbers of threads. And you can see that it's, and I've done it with some of the other tools as well. It's been fairly consistent that 8 is what you want to set it to. From 1 to 8 you get a fairly nice reduction in the computing time, and then it basically levels out. In fact, it goes up surprisingly slowly. If you run 32 threads, you expect the overhead to really start to dominate. It doesn't. Anyway, David TauDEM's only remark on this is that the number of threads should be the same order of magnitude as the number of cores. From my experience, it's worth running it with somewhat more than you have. The other thing, though, is that I suppose I'm slightly disappointed. I've got about 30% reduction in time. Now this is taking 2,200 seconds, or about 25 minutes or something. So cutting, you get slightly shorter coffee break than you might otherwise have to take. But it's not a huge difference. It's some difference. The real point is that you can deal with much bigger ones. I think that's the real bonus. Now, so I was trying to get essentially the same interface so as not to interfere with things too much. I'm trying to make the installation easy. I failed that the first time, but that was my aim. I made a mess of that. The new one, I think, is okay. And I don't want to spend my life trying to rewrite this stuff. I never didn't do AWD in the first place. I just happened to be a user of it, so I got forced into the position of having to maintain it for a while. But I don't want to do that forever. TauDEM used to be a single DLL. Now it's 25 separate executables, so there's a lot of tedious change just to deal with that. Installation of MPI CH2 is a real pain. a lot of the discussion on their website, or at least on their user groups, is how do I install it, because it keeps not working. You need to set up a path, you need to give a username and a password, and although we're only using it in a very simple way, so my first attempt got entangled a bit in that, and other people said, no, you can't do that. Most of our users don't want AWD, and they don't want all this pain, things go wrong with the installer. So, now the approach is that if you just install MapWindow and don't do anything else, then you'll get the single thread use of TauDEM. There's a little bit more going on at the bottom than that, but essentially you don't have to install MPI at all. You do in fact have to have some of the DLLs around or the thing won't run, but that's just quietly done. So if you don't want AWD or your customers don't, then you don't have to say anything, essentially. The other advantage, if you want to get the improved performance, or you want to be able to deal with the much larger files, then you can install MPI, and then the MapWindow will discover that the MPI program manager is running, and will use it. If it doesn't discover it running, it says, okay, not there, and it doesn't use it. The TauDEM executables run in a minimized window. I started out with a hidden one, but I discovered that occasionally it can stall. And if the window is hidden, it's very hard to really have to actually stop everything to get out of it. So at least although you get the disadvantage that the minimized window sort of appears and disappears on the bottom of your screen. But at least if it stalls, you can open it and Control-C to get rid of it. And the output is optional. Well, it'll always show the output from TauDEM if there's an error, but as long as there are errors, you never see it. Unless you want to do some tuning, because if you look at the output, it gives you some numbers about, I'll skip over that somewhere later, but this is the typical output from TauDEM, and it's got some numbers. So if you want to tune to find out how many processes it's worth running with, then you can do it. So, we've improved watershed delineation, obviously someone else has, not me, by using MPI. And perhaps it's time we started catching up with our hardware capabilities in our other tools. Thank you.